builds an assembly, it embeds ECAD data in it from the IDF file, and this data can be used in a number of ways. Firstly, if we have a look at one of the components, if I open, for example, this component here in a separate window, if you look at its custom properties, these properties here have been automatically added by CircuitWorks, so it's added the part number and the package name automatically to the custom properties of the model it's created. Now these custom properties can be used in things such as drawing boards and bills of materials, and even in PDM, so you can link the properties in the model through to your PDM system. Now, as well as these couple of properties it adds automatically, if there are properties defined in your ECAD system and you're using the IDF3 or the IDF4 formats, these custom properties will come through into CircuitWorks and then on into SolidWorks. So for example, you could have a property like resistance defined for a resistor in your ECAD system. If you saved the file out as an IDF2 or 3, an IDF3 or 4 file, and then brought that into CircuitWorks and brought then into SolidWorks, you'd end up with those custom properties in the SolidWorks model, which you could then either use in a bill of materials, use in a drawing board, or use with a PDM system such as PDMWorks. If we return back to the assembly, now as well as embedding information in parts, there's also ECAD information embedded in this assembly, and I can use these three tools here to use that information. The first tool, for example, is the component information tool. So if I click the component information icon and then select different components in the assembly, you'll see as I select the components in the assembly, so the package name of the part number and the reference designator of that component instance is displayed. The same goes from using the tree. I can select things in the SolidWorks tree and see their ECAD properties as well as their SolidWorks properties. I've also got this ECAD information, and this is embedded in the SolidWorks assembly. I don't need the IDF file to be present on the computer anymore to get this information. It's actually embedded inside the assembly. So for example, if I selected this screen, I could change its reference designator from H1 to let's say 199. Update, close, and that information is now saved inside the SolidWorks assembly. So now, for example, if I was to export this SolidWorks assembly back out using CircuitWorks as an IDF file, that updated custom property information, that updated reference designator, would go across into the IDF file and obviously back into the ECAD system. So changes made to the reference designators in SolidWorks can be taken all the way through and back into an ECAD system. The next tool we've got in the toolbar is Annotate. Again, that uses the same information. If I move the Annotate, move it onto the screen, you can see we can add annotations for use in things like assembly drawings. So you can literally annotate each component instance with information. So I can add its reference designator, its name, its part number. I can stack annotations on top of each other. So I can have two annotations, I could have name dash part number, something like that. I can choose which board side I want to add the annotations to. If I press add, I can automatically add the annotations to, in this case I'm adding them to the top of the board, and I'm just adding the reference designator information. So once this is finished, I should be able to see all the reference designators displayed on this assembly for every single component. What I can then do is take this SolidWorks assembly model, put it on a drawing sheet, and I'll then have a SolidWorks model, SolidWorks drawings, with every component instance annotated. So I could then use that, for example, as a build sheet. I could give that document to somebody and they could have a picture of the circuit board, its components. They'd know which component was which one was V125, which one was C203, and build it up. If I now look, it's now finished, and then you can see all the annotations, obviously a bit jumbled. You can change the font sizes in SolidWorks, of course. And there's the H199. This was a reference designator I changed for the screen. You'll see that reference designator has now changed from H1 to H199. And I can take them all off again. Let's remove all the reference designators. So I'm just taking them all off the model again. So again, that's a very useful tool for annotating drawings, again for producing visual drawings that you can use as build sheets, that kind of thing. Okay, that's the annotations removed. The final tool allows us to locate a component in the assembly. If I press the button, it will display a list. Again, bring it back onto the screen so we can see it. This is a list of all the components in the assembly. And this cross-references the reference designator, the SolidWorks part number, the CircuitWorks component number, because they won't necessarily be the same thing, especially if you've added components manually to the library, the part number, the ECAD part number, its X, Y position, and its board side. And again, by clicking on these headers, I can sort components by side, by X position, that kind of thing. If I select an item, and again if I can get this out of the way, it will actually highlight it. Let's try it. Let's try a larger component we can actually see. If I find our component H1 that we were looking at earlier, let's bring that down on screen. Here's our H199. As you can see, this is the LCD screen we were looking at earlier. If I select it here, it will highlight it. If I double click, it will zoom in. So again, I can move my way around the assembly, locating parts, double click, zoom in on them. So we've instantly there got a cross-reference between electrical information, the reference designator, the electrical part number, the electrical component name, and the SolidWorks part number. So we can always find components in the SolidWorks assembly by their electrical information. Okay, let's zoom back out again. Now the next thing I'm going to do is modify this assembly so we made an obvious change the shape, move components around, that kind of thing, and then export it back out as an IDF file to show that CircuitWorks is a bidirectional system, and as well as generating SolidWorks models, it can also take SolidWorks models and export them back as IDF data, and we'll look at that in the next video.